Hello, everyone, and welcome to Telecom Talk Live. Today, we are talking about something most AI conversation ignore, the physical network that actually makes AI possible, the fiber, the fieldwork, and the real infrastructure behind it. And to discuss this, we have a very special guest with us, Mr. Stephen Rose, who is the CEO of Render Network with over 25 years of experience across IBM, Nokia, and Bell Labs in telecom, technology, and digital innovation. He holds a master's degree from the University of Oxford and is based in New Jersey. Stephen, welcome to Telecom Talk Live, and it's a pleasure to have you with us.
Yeah, it's wonderful
Yeah,
to be
it's
here.
wonderful to
Thanks
be
very
here.
much for
Thanks very much for
inviting me.
inviting me.
Okay. Stephen, to start with, for our audience in India and the telecom space, what exactly does Render Network do? In simple terms, what problems are you solving in the ground?
Yeah, so
Yeah,
you can
so
imagine
you
we're
can
essentially the digital infrastructure for the deployment of, or sorry, the digital operating system for anybody that is deploying a telecom network or even an electric grid. So it doesn't matter if it's fiber or it's 5G. Essentially, what we do is we take the design of that network, we infuse it, or we bring it into our platform, and then we take out all of those designs and break it down into the thousands of activities. Sometimes there are hundreds of thousands of activities that need to be deployed on these networks. We sequence them, then we logically put them together in such a way that you can actually take that work, apportion it to different crews, get the work done, and then essentially the crews use field applications, our field application, to be able to report back on the work and close out. Yeah, and so effectively you have a very real time sense of what is actually understanding. You get a digital twin of the network. And then you also have a complete data set for the system of record and before you go into operations and maintenance. So a very solid system. It uses a lot of clever AI and automation to do that. And really, depending on where you sit, if you're an investor, you want to know exactly what the state of your investment is. If you're an operator or your construction firm, then ultimately you also want to understand and be able to plan your construction properly. So that's what it does.
Render works with telecom operators and fiber builders across countries. What inefficiency did you see in traditional fiber deployment that led to starting Render?
Yeah, I mean, again, if you just think about it in real world practical terms, in the old days, you would take or even in current days, you would take a blueprint, and you would have that physical blueprint. You put it over the hood or the bonnet of a car, or a truck, and you would actually then figure out what to do, and then all of the reporting that you would actually do would be done via an email or via a phone call or whatever else. It's an incredibly inefficient way to do things. So the inefficiencies really start at the beginning of taking a design into a construction platform, because you then have to track all the milestones, you have to plan all the milestones up, you have to then figure out what crews are going to do what work and what is the state of build across hundreds of different locations. Doing that manually is largely impossible. And then, of course, when you're doing the build, trying to figure out what the state of the network is, and if things change, are crews available, are systems available, or resources available? There's a lot of manual intensity in there. And then the crew themselves, if you imagine you've been out in the field all day, you're tired, you're hungry, you finished a day of work, and you still have to go home and then report out on what you've managed to complete for the day via an email or a text message or something. It's all, there's a lot of inefficiency in all of that. We close all of those problems out just through a singular system.
Can you share some of your recent milestones or achievements Render has had in the last, let's say, 12 to 18 months? Be it deployments, like the countries where it deployed, the kind of operator scale that it has, and some of the recognitions.
Yeah, I mean, our platform is probably over the last 10 years, I would say, been able to support the deployment of billions of dollars of technology, literally. But over the last 12 to 18 months, the real focus has been on two things. One is being able to scale. I think these platforms have gone from being project-based platforms to actually entire operating systems. So if you're a construction firm, this platform effectively becomes the operating system for your business. You live and die by it. Now, when you do that, you've got to be able to scale to hundreds of thousands of activities. So I think that's a big part of what we had to do. I think the second, and that's obviously for them, for the tier one operators, tier two operators that are deploying. I think the second thing the major milestone is really in the infusion of AI and automation. So we've been working with Databricks on that to actually make sure that we have a data analytics platform running. And that really is then about having the insight, the foresight, and the cross sight to be able to understand what is the state of your deployment at any one moment in time. Then the last bit is really the introduction of things like visual inspection, being able to actually use one of these devices here to be able to figure out, or an iPad to figure out actually how do you do quality control at the end of your closeout, so that actually then you have the data and you have the analytics all coming together. So, in this world of data and AI, there's a lot of new milestones to be achieved.
So now, Stephen, everyone is talking about AI models and applications, but very few talk about the infrastructure needed underneath it. So, what changes in the physical network world when AI becomes mainstream? Like, what are the changes that's gonna take place? Is it gonna be a lot of changes on the physical core network?
So I think what you will really see is an augmentation of humans rather than a replacement of humans. I think that's the most important thing to understand. So if you're in the back office, rather than actually manually figuring out where to deploy resources, or where the what the state of the build is at any one point in time, you're actually going from managing to leading. Yeah, and I think that's a very, very different type of problem to solve for, because you're actually then predictive in the way that you're working, you're proactive, whatever phrase you want to use. That is a completely different class of expertise. I think then when you go into the field, then you also see a very different way of working. The field will be, of course, the AI isn't going to dig the hole for you. But actually, if you think about, if you're using a bore machine and that bore machine is actually digging out the ground, the analytics or the telemetry that's coming from that bore machine is then being populated directly into our platform. And then you can actually figure out, to a greater or lesser extent, without a lot of, again, a lot of manual intervention, whether or not that bore adders needed to be, added into an invoice, for example. Somebody would normally have to be manually dealing with that. Instead, you'll be able to actually get the system to tell you how much of the bore adder is legitimate in the invoice based on the telemetry come out of the system, or whether or not the QA um, criteria have been met, uh, again, automatically through a number of visual inspection controls. The last point is probably a speech to text. Again, what you'll be able to do is actually talk into these systems and get them to do the work for you, rather than actually then having to figure that out with a muddy finger and a broken screen. So, again, a lot of small things, but when you add them all up together over the value chain, they add up to a lot of change and progress, or let's say, productivity.
From your perspective, like how different is the network requirement for the AI era compared to the cloud era we saw last decade, right?
Well, I think you will definitely see. I mean, this is a slightly different thing, but I think we're still going to be involved in this. I think, the shift to edge networks is definitely going to be there, and I think edge AI and edge computation will be a continuum in the network, and I think that means that You're going to put less strain on the backbone. You're going to put less strain on what is actually going on in the centralized systems, because more compute and storage will be moved to the edge. And I think in our part of the world, you will absolutely be able to see that. Whether it be you've got the ability to actually then interact dynamically with platforms, and then those platforms will be able to provide maybe live data feeds. I mean, I'll give you a working example. It could be that you're setting up visual inspection systems that are actually monitoring the safety protocols for a particular site. Now that would be a really interesting way of doing things, because then you could actually have crews that are making sure that the health and safety requirements are being adhered to, and not just reporting out on the progress of work. So I think there's a lot of opportunity for networks to be able to provide a lot of new value, but really around the edge and AI capabilities.
And what is the biggest bottleneck today, like preventing countries from being truly AI ready, compute or connectivity, or is it the execution speed? Like, what are the challenges countries are facing right
So I think if you look at the velocity of the business cases around AI and data centers, I think they are moving at a prolific rate. I think the problem is that the networks, whether it be uh, um, the electric networks, or whether it be the water networks, or whether it be the telco networks, they have to work in tandem. So coordinating that, making sure that it's ready to be able to actually meet this, that kind of velocity on the AI and data centers. They're at two speeds right now, so there's a problem there. I think the real problem, though, and what slows organizations, or even at the macro country level, is this notion of AI first. And I don't see enough focus around change leadership. I think firms need to prepare their organizations and their leaders for that change. I think it starts there. Once you get the change protocols in place and the change expertise inside of the organization, the rest tends to follow. But if you try and force technology into an organization and then somehow expect it to be adopted, I think you're fooling yourself a little bit.
What about the today's telecom and fiber networks design? Are they designed for AI traffic patterns, or were they designed mainly for video streaming and internet browsing?
I think historically they were really designed for, downlink. But I think there is a progressive move to symmetrical uplink and downlink. Now, I haven't seen enough of the use cases around that necessarily to be able to warrant that, because of course that's expensive, and the rest of it. But I think for the most part, the networks are able to cope. There's a lot of capacity still in these networks and whatnot. I think the focus for the networks going forward is resiliency. Those networks are going to be running critical AI infrastructure. So if your Netflix session goes down for a minute, or it takes 30 seconds to download, you're not or to become ready, you're not really going to be that bothered about it. But if you're running high sensitivity AI applications that require real-time analytics, whether it be for manufacturing firms, or whether it needs to be something that is pressing for government, those applications will need to be running in with very, very low latency, number one, and very, very high levels of security. I think that's exactly where the focus should be going forward.
And we hear about GPUs and data centers. Like, how critical is the last mile and field networks build quality in the AI age?
Well, actually, if you look at the cost of deploying a network, the last mile probably represents 70% of the cost. It's where you lose your shirt on a network, because you've obviously got complex, small levels of details to navigate. So I think the last mile is actually where the criticality of a network deployment can be, or sorry, should be, sort of assessed very, very carefully. And again, that sort of puts or sorry, not sort of, but that puts the justification for why the investment in these types of platforms is critical going forward. It seems kind of odd to me always that somebody would be very happy to run the deployment of very, very critical infrastructure on the back of an Excel spreadsheet. But if you suggested the same to do the same on your billing system, you would be appalled at the idea. Yeah. So, but actually, if you look at if you look at the deployment of network infrastructure today, 98% of them are late, and 98% of them come above budget.
Okay. So, Stephen, bringing this to India, like India is rapidly expanding, be it fiber, 5G, and data center capacity. From what you see, like what must India get right now to avoid becoming a computer-rich but network poor for AI?
Yeah, so I mean India operates on a scale like no other country pretty much. I mean there's only a couple of other countries in the world that really operates on that scale, and a small network deployment in India is an entire country in another, sort of in another location. So I think scaling for the opportunity, and if or the problems that in deployment of network infrastructure in India is going to be the number one concern. Have you got systems and processes and systems of activities that can cope with the deluge of data and the deluge of activities that are happening concurrently in the network? You've got to be able to manage that really well, whether you're deploying a wireless network, a wireline network, or the physical infrastructure of an electric network. I think the second thing is coordination at the, whether you're going to do it at the regional level, or whether you're going to do it at the local country level. But coordinating those different systems is also going to be a big part of the problem, because there's little point in having a massive amount of network infrastructure being deployed only to find that you can't light it up, or that you can't power it, for weeks on end, simply because there are delays in permitting and uncoordinated systems around that. So, India has got a massive challenge, but we've also seen India, sort of scale to that challenge in the past. So I'm sure they'll get there.
And what role does automation and software like Render play in speeding up fiber and infrastructure deployment for AI readiness?
Yeah, I mean the biggest thing is it takes the risk out. The first thing, you can understand what it is that you need to be doing well ahead of, sort of getting into the field. So, and the biggest challenge you've really got to get is that the delta between the design and the as built is something in the region of less than 5% deviation. If you can get that, you're deploying a network very, very efficiently. I think the second thing is rework. Just the simplest of things, using visual inspection, for example, to make sure that if you're digging, a trench, the trench is, sufficiently deep enough, etc., and that the quality of that means that the crew doesn't leave, go, 20 kilometers, 20 miles down the road, whatever it is, and then have to go back the next day and do the rework. Using AI and automation to actually pick up those problems early and intercept them means that you're going to change, sort of 30% of the wasted capacity that happens on these deployments.
Stephen, in the next 5 years, like what will AI demand from telecom and fiber networks that they are not ready for today?
Um, Again, I think that you will see what we're seeing, is a lot of understanding and education going into uh, the infrastructure systems. Yeah, so whether you're or sorry, not infrastructure systems, um, enterprise systems. I think enterprises have become so much more educated around the potential for that intersection of AI, 5G going towards 6G, of course, and then fiber networks. So I think those network systems, the resiliency of those networks, as I talked about before, when there is big dependency between industry standards, industry regulations, for example, and those network systems, that's where the networks have to be ready and prepared for. And I think AI will explode the amount of use cases, the levels of automation and sophistication. The network resiliency really has to keep up with that. So going from even the simplest of things, making sure that the data from the construction phase going into the operations and maintenance phase, having a very sophisticated system and a credible loop around that is going to enable you to react rapidly to any kind of issues on the network and proactively deal with them.
Will we see a shift from centralized data center to more edge-heavy AI infrastructure?
Yeah, I think so. I think there are physical reasons why. I mean, of course, you would love to be able to centralize everything for scale and low cost, but the reality is the law of physics compels us differently. Yeah, if you are wanting something that is 20 milliseconds or latency, and probably even at some instances maybe sub 10 millisecond latency for certain use cases, then you cannot have super centralized systems. You're going to have to move to edge computation and storage. So I think there will be that, but I think they're going to be specialized use cases. I don't think you're just going to see them. And then it'd be very interesting to see if the cost of compute and storage goes down sufficiently so that these solutions can be provided uniquely to big manufacturing plants, for example. Yeah, but yeah, no, there is a great opportunity, and of course for fixed and mobile convergent players, they've got the physical infrastructure deployed at the hyper local level to be able to take advantage of that. So you effectively be converting base stations into mini servers at some point or another.
And if a telecom operator wants to be like truly AI ready, like what are the top three things they must start doing today?
Well, as I say, I think the first one is change leadership. Get that right, and I think the rest will follow. I think the second one is distributed experimentation. I see a lot of firms and they're playing with AI and they're thinking about how to use it. They set up this special focus group, and that special focus group becomes the controlling point. I don't think that's a very clever way to deploy AI. I think you should, in the same way that you have any kind of policy in a company, um, create the right conditions and the right policies, and then get your employee base to experiment as much as you can with the AI technologies. I think the third thing I would really do is make sure that you understand and categorize the kind of use cases that you're going to see, useful, and then experiment on them and get your value chain involved in that as well. If you get your value chain in, it means that you don't have to do all the research on the best way to adopt and apply AI. Build an ecosystem around that, and then your learning curve will go up a lot faster.
Countries are also investing billions in AI. Should they be investing equally on the, let's say, field network execution technology or on the field? Like,
Well, I'd love them to be investing billions because then it would be going to render but I doubt that they'll be doing that. But I do think that there needs to be a profound change in the way that they think about how to deploy the technology and what is the cost. And I think there is an obsession around TCO in telco operators typically, and I kind of get that in a certain way. But I often think that the TCO obsession is in the wrong place. So I think if you're looking at, whether you're going to spend, whatever amount of money on these kinds of platforms, and they pale by comparison when you make the mistake. The problem is that of course the cost avoidance is a potential, and then there is the reality of actually, what a system like ours cost. So I think you have to do your business case cleverly and have faith in the fact that, and also look at your history to remind yourself that you've been spending way more than these platforms cost, just to recalibrate on the risk that you've taken.
so Stephen, like we are getting couple of questions from our audience. Like, can I take one or two if it's okay?
Sure, absolutely, go for it.
So there is this one question from a user who says that like render focuses heavily on real-time field data capture. How does this data change decision making for operators during live fiber build?
Yeah, it's a great question, actually. So typically, what you would have is you would have fragmented sets of data coming in from different field organizations, so field teams, crew one, three, four, and nine, all sat in different locations. So actually, if you have non-real-time data coming in, then the first thing is that the supervisor or the the next layer of management has to figure out what is the reality of the situation. And if you're getting different cutoff points, or you're getting different versions of the data in different formats, it's a very difficult thing to do. I think the second thing is just the re-coordination of the resources, and making sure that you're deploying your network relative to where you're going to make maximum return on invested capital. So if you've got insight, coming in from your crew saying, I finished on site X, and site Y is going to be, sort of way more in terms of, the adoption rate or the take up rate is going to be much higher. You deploy that crew to that location the next day. So next best action decision making is a lot more informed and a lot more sophisticated.
Okay, so there is this another question like, how does render standardize work across multiple contractors and vendors in the same project?
Yeah, that's always a difficult one. Again, it comes to change management and adoption. We work with often with tier one construction firms who've got a bunch of subcontractors. What we do is we pilot, typically with one or two, sometimes three concurrently. We look for the ones that are going to be early adopters, and they are, let's say, enjoying the notion of adopting AI practices into their work. Once we get them onboarded and we get the MVP or the POV, whichever phrase you want to do, um, qualified and everybody is bought into it, then we'll progressively roll out to a wider group of contractors. And some of these general contractors have 15, 20 contractors on them. So it is important, but going in with a big prang approach and trying to get everybody onboarded at once, yeah, that's likely to fail. Start in the corner and then light the fire across the room.
Okay, we are still getting more questions. You want me to take, or is it okay? Should we
Go for it.
chop?
Go for it. I'm all yours.
Okay. So there is this another question like, how many concurrent field activities can the platform realistically manage in large national rollouts?
Yeah, I mean,
You,
some of these things are we're running up to nearly 500,000 concurrent activities on these networks. So, that is a huge number of concurrent activities. And like I said, if you're a tier one construction firm, you're running multiple contracts, multiple subcontractors all concurrently. So yeah, these and that's where we invested very heavily over the last 6 months. It was a requirement of our biggest customers because they were, operating at, sort of national scale in the US. If you're running small countries and small projects, not a worry, but a country like India is going to need scale like ours.
uh, Operators often depend on reports from contractors. How does Render provide real-time, trustworthy visibility instead of delayed reporting? I think
Yeah,
these are vendor
these are
questions.
great. Yeah, no, they're very valid questions. I mean, I mean, this is a sort of problem that, you want to be able to performance manage your contractors, and you don't want to always be in a situation where you're penalizing them and running to the contract. So there's a lot of metadata that gets captured during the build phase. So when the contractors are actually sending in imagery or when they're actually reporting out, we can take the metadata and we can actually capture, what the state of the deployment is at any one moment in time. Um, I think the second thing is that again, because we're using a great deal of data, whether it's coming from third-party integrations that we've got, yeah, whether it be, for QA kind of work, or whether it's the telemetry coming from bore machines, for example, or whether it is, actually somebody's just taking photos. When you actually take all of those bits of data and you can actually correlate them, then you get a very solid set of data, and then it takes the doubt out of any decision making.
And probably this can be the last one, I guess. Although we have like 50
Okay.
questions, like how does Render help operators reduce what is it, rework and improve productivity without increasing the manpower?
Yeah, I mean, again, what we typically do is because the real-time data is going to a supervisory level that is able to understand the next best action. That is, a massive way of actually just avoiding the rework. And again, I talked about it earlier. You're seeing imagery coming in real time. You're using AI to be able to say the probability of this particular photo being accurate and the work being accurate and compliant to the contract term. That is a percentage of X. And if it goes below, let's say, 85%, you're probably going to make a phone call to the crew manager and say, are you sure you did the right kind of work there? But it just stops a supervisor having to go through every single report manually and figure out whether or not they have to take action on that. The system will tell you, actually, you need to focus here and here and here because there are anomalies. So it's anomaly detection, or it's looking at the delta between the the desired state and the actual state being reported, and then that's where the focus goes. There's a lot of time wastage that we avoid because of that.
Stephen, this has been very insightful conversation. Like you have brought a perspective that most AI discussion completely misses. And even like I'm pretty sure, I believe there were a lot of vendors and telco operators who are listening, and they have still have more questions. Probably, maybe we can sit again in some other session. Probably, although this was meant for only for 30 minutes. So, Stephen, thank you so much. We will connect again, and thank you again. Thank you once again. Bye,
My
Stephen.
pleasure. Thanks.